Draw a molecule of propene, circle a functional group, then draw a section of a polypropene molecule containing 3 repeating units. So 2 questions here. Propene first. Prop has got 3 carbons because prop tells us it's 3. It's an ene, so it's an alkene. The functional group of an alkene is a carbon double bond carbon. So it's got 3 carbons and there's got to be 1 carbon double bond carbon. I'm going to put it this side, but you could put it there. Most important thing is carbon can always form 4 bonds. So let's add 4 bonds around all these carbons now, and this is the bit people get wrong. This carbon's got 1 bond around it. 1, 2, 3 more makes 4. All right, this is the one you're going to get wrong, probably, if you're going to get one wrong. It's this middle carbon. Count the number of bonds around it. 1, 2, 3. It only needs 1 more. Most people put 5 bonds around that carbon. It only needs 4. 1, 2, 3, 4. This carbon there, 2 bonds already, so it needs 2 more. 1, 2. Now we've done that, let's add hydrogen to each of those bonds, and we've got propene. Okay, second part of the question. What does a molecule of polypropene look like? Okay, I'm just going to draw this box off here because I want to use this bit as rough. Okay, when we did addition polymerisation, because that's what this is, addition polymerisation, I told you this is the shorthand equation for every addition polymerisation reaction. And if you don't draw it like this, you are going to get it wrong. Okay? N of those and N of those. I often ask classes to do this, and I say draw polypropene, and I say if you don't start with this, you're going to get it wrong. And then people start putting through a 3rd carbon here and then a 3rd carbon in a chain here, and they get it wrong. Okay, this is the right answer. Okay, but we've got 3 carbons here. People shout. Well, the carbon double bond carbon still goes there, and there it is there. And on this carbon here, one of the bonds is to a carbon, one of the bonds is to a hydrogen. So on this carbon here, one of the bonds is to a carbon, let's say a CH3 group, and one of the bonds is to a hydrogen. On this carbon here, we've got 2 hydrogens. This carbon here, 2 hydrogens. Can you see how what I've drawn there is identical to what I drew there? Okay, I've just changed the angle of the bonds. But of course, propene doesn't look like this anyway. We only draw it like this just so we can see the bonding and the structure. So changing the angle of the bond is absolutely fine. So whatever we've drawn on these bonds here, we have to draw on these bonds here. CH3, H, H, H. So that's 1 repeating unit. That is 1 repeating unit. Okay, and the important thing is the repeating unit has 2 carbons in the middle of it, okay, and then the bonds go out through the brackets because that's where the double bond opens up in addition polymerisation. The double bond opens up. So that's 1 repeating unit. We've got to draw 3 repeating units down here. So we've got to draw this C, CH3, H, C, H, H. So that's what I've drawn there. Yes, are we happy with that? Okay, that's 1 repeating unit. So we've got to draw it 3 times. Just copy it 3 times. C, C, so that's got a CH3 on it. H, H, H. That's 2 repeating units. We've got to draw it for 3rd time once more. CH3, H, H, H. There we go. So there's a section of the polymer molecule containing 3 repeating units. 1 is there, 2 is there, 3 is there. The important thing is, as I said, each repeating unit has 2 carbons that form part of the longer chain, not 3 carbons. A 3rd carbon is off on a branch with propene. All these questions on elshamhighchemistry.com.